Hello class, welcome to this video on the 5.5 review for statistics, probability and statistics. So let's take a look at the problem sets here. Starting with problem set 1, which is talking about using the general multiplication rule. So it says students who work at a local coffee shop recorded the drink orders of all the customers on a Saturday. They found that 64% of customers ordered a hot drink and 80% of these customers added cream to their drink. Find the probability that a randomly selected Saturday customer ordered a hot drink and added cream to the drink. So we have a randomly selected Saturday. Okay, so we have they ordered a hot drink. So I'm going to put the probability of we got the hot drink and cream. Actually, let me just use the symbol here. So we'll say H is for they added a hot drink, and then C is for cream. So we have the probability of hot drink and cream, and according to the general probability rule or the general multiplication rule, you multiply the two probabilities with the conditional for the second one, given H. So the general rule, which I'll write down here, is P of A and B equals P of A times P of B given A. All right, and so here we have the probability of a hot drink. They mention in the problem 64%, so it's 0.64. And then the probability of cream given hot drink, it says 80% of these customers, so that they actually give you that number. Okay. All right, and you multiply those two probabilities together. So do that over here. Okay, so we got 0. Should be say 0.64 times 0.80. All right, so you get 0.512. Okay, so 0.512. All right, so now number 2, suppose that 10% of adults belong to health clubs and 40% of these health club members go to the club at least twice a week. So we'll say H is for health clubs, so H here, and then goes there at least twice a week. So at least twice a week, so we'll put T for twice a week or more. All right, so we want the probability of health club and goes at least twice a week. So that's the probability of the health club times the probability that they go twice a week, given that they go to a health club. And then the probability of health club is 0.10 or 10%. Multiply that by the probability here, the conditional of 0.40. And so we get 0.04. Okay, so for number 3, it says, according to Forrest Gump, life is like a box of chocolates. You never know what you're going to get. Suppose a candy maker offers a special Gump box with 20 chocolate candies that look alike. In fact, 14 of the candies have soft centers and 6 have hard centers. Choose 2 of the candies from a Gump box at random. Find the probability that both candies have soft centers. Okay, so here we want both have soft, so we'll say S. So the probability of soft and soft is the probability of soft for the first one times the probability of soft for the second one, given that the first one was soft. So for that. So for the probability that the first one is soft is 14 out of 20, right? There's 14 that have soft scores. And then the second one, once you pull that one out and eat it, then you're going to have 13 left out of 19 candies. Some students forget to reduce that to 19, so make sure you do that. All right, and then you multiply those two probabilities together. 14 out of 20 times 13 out of 19, get 0.4789. Okay, so 0.4789. All right, so number 4, statistics class with 30 students has 10 varsity students and 20 who are not. Choose 2 of the students in the class at random. Find the probability that they're both not varsity. So the probability of not varsity. Okay, so we'll say varsity prime. V is varsity, so we'll say varsity prime. So not varsity and not varsity. Well, and that's the probability of them multiplied, right? So the probability that the first one is not varsity, well, there's 20 of them. They're not out of 30. Once you select one, you have 19 left and 20 out of 29 students. And you just multiply those together. You got your answer. Okay, so you got 0.4368. All right, so the next problem set is about making tree diagrams in order to calculate probabilities. So number one, in a recent month, 88% of automobile drivers filled their vehicles with regular gas, 2% purchased mid-grade gas, and 10% bought premium. Of those who bought regular gas, 28% paid with a credit card. Of customers who bought mid-grade and premium, 34% and 42% respectively paid with a credit card. Suppose we select a customer at random. Draw a tree diagram to model this chance process. Okay, so here we got regular gasoline, right? We got mid-grade, and we got premium. Okay. And it says that of those who bought regular gas, well, it says 88% bought regular gasoline, so 0.88. This one's 0.10% for mid, and then this one, or 2% rather. And then 10% bought premium. And then regular, we got credit card versus not with a credit card, right? Credit. Not credit. All right, so it says of those who bought regular gas, 28% paid with a credit card. So that means 72% without. Of the customers who bought mid-grade and premium, you got 34% for credit and 42% for credit. So then that means mid-grade, this has got to be 0.66, and then this has got to be 0.58 because they have to add up to 1. All right, find the probability that the customer paid with a credit card. So that's going to be this pathway, and this pathway, right? And so what you do is you, as you travel that pathway, you multiply the probabilities along the way. Okay, so we're going to multiply this path, those two probabilities. So probability of credit card is 0.88 times 0.28 plus the next pathway, mid-grade and credit, 0.02 times 0.34. And then we got 0.10 times 0.42. All right, and then so you would go ahead and add that together and see what we get. So 0.88 times 0.28. Here, 0.2952. All right, that takes care of that one. So let's look at the next one. Computer company makes desktop and laptop computers at factories in 3 states. California factory produces 40% of the company's computers, Texas for 25 and 35, New York. Okay, so we got those 3 stages: California, Texas, New York. So we got 40% here. We got 25% for Texas, and then 35 for New York. And then of the computers made in California, 75% are laptops. So 75% laptops. This one's not laptops. And then Texas, 25. It says of those in Texas, 70% are laptops. Okay, so 70%. That means 30% are not. And that means this one's 25% are not. And in New York, it's 50% are laptops. That means 50% are not. All right, and there's our tree diagram. So find the probability that the computer is a laptop. So probability of laptop. So that's this pathway, this pathway, and this pathway. We're going to do this, this, and this. So we're going to multiply those probabilities along the way along those three red pathways. 0.40 times 0.75, 0.25 times 0.70, 0.35 times 0.50, and we add those together. Okay, so we have 0.65, so 65%. All right, so according to Forrest Gump, life is like a box of chocolates. You never know what you're going to get. So the same idea. It says choose two of these candies from Gump box at random. Draw a tree diagram. Okay, so we got the first stage. We got soft and hard. And then after that, we got soft and hard again, right? So this one is 14 out of 20, right? And then this one is 6 out of 20. And then if you pull a soft candy, then the probability of getting another soft is 13 out of 19. And then this one's 6 out of 19. And the probability, if you pull a hard candy for the first one, the probability of getting a soft one is 14 out of 19. And then this one's going to be 5 out of 19. All right, so there's your tree diagram. Find the probability that one of the chocolates has a soft center and the other one doesn't. So the probability of soft and, now this is tricky, that one of the chocolates is soft, the other one it doesn't have it. So that means they're asking for one of them is chocolate, one of them is soft, right? So that means it's this pathway or this pathway. So it's just one of them is soft. So that means it's this pathway or this pathway. Okay, so you got two pathways. All right, so we got 14 out of 20 times 6 out of 19 plus 6 out of 20 times 14 out of 19. Okay, and you multiply those together and get your final answer. We'll get that as a decimal here for the final answer. Got 0.4421. All right. So also got problem set number 3, and that should be the last problem set in that exercise. All right. So here we're setting up a tree diagram, but this time we're doing conditional probabilities. Okay, so that's what we're trying to set up. All right. Tennis great Roger Federer made 63% of his first serves in a recent season. When Federer made his first serve, he won 78% of the points. When he missed his first serve and had to serve again, he won only 57% of the points. Suppose you randomly choose a point on which Federer served. You get distracted before seeing his first serve, but you look up in time to see Federer win the point. What's the probability that he missed his first serve? Okay, so we have he made for the first serve, right? So I'm going to say F for he made his first serve, okay? So that's going to be F. And then C, and then he says, what's probably, and then it says he missed his serve, he had to serve again. Okay, so first serve he made, first serve he did not make, okay? So it says 63% of his first serves he made, which means that 39%, or 37% rather, he did not make, right? Well, he did not win. Yeah, he did not make his first serve. Now it says when he makes his first serve, he won 78% of the points. So let's see, 1 is W, okay? So 0.78. And then this has got to be points 22. He did not win. When he missed his first serve, so that's F prime, and had to serve again, he only won 57%. So 0.57 of his points. And then this one's got to be 0.43. Okay, 43%. Now you randomly choose a point on which he served. You get distracted before seeing his first serve, but look up in time to see Federer win the point. So you see that he wins the point. What's the probability that he missed his first serve? Okay, so we know that we're given that he wins the point. So we're given that, we know that. Then what's the probability that he missed his first serve? So that means F prime. So this is what they're looking for. And so we have to use a conditional probability. So F prime and W divided by the probability of W. So remember, the conditional probability is calculated by doing the probability of both divided by the probability of the given. Okay, so that's the formula, if you will. All right, and so what's the probability that he wins the point? Well, there's two pathways for that, right? So you could do that, and then so basically, the number 2 pathway you're going to do in the numerator, right? And then number 1 plus 2 you're going to do in the denominator. Okay, so in the numerator you're going to do the 0.63 times 0.78 because that's where he misses it, or not 0.63, 0.37, which is the bottom one, times 0.57. So that's where he misses and he wins, right? That's the first part. And then divided by on the bottom, you got to do the number 1 and 2 pathways. So 0.63 times 0.78 plus 0.37 times 0.57. All right, so let me go ahead and do that. So we got 0.37 times 0.57 divided by parentheses 0.63. You got to be careful when you do this because you got to put parentheses when you do the denominator, okay? Plus 0.37, or do it like separately so you don't mess it up. All right, so you got 0.3003. There's a 30% chance that he missed his first serve. If you didn't get a chance to look and you were to guess, then you would be the 30% chance that you would guess correctly if that's what you guessed that he missed. All right, so a boy uses homemade metal detector to look for valuable metal objects on a beach. The machine is imperfect. It detects only 98% of the metal objects over which it passes, and it detects 4% of the non-metallic objects over which it passes. Suppose that 25% of the objects that pass over the machine passes over are metal. Choose an object from this beach at random. If the machine gives a signal when it passes over the object, find the probability that he has found a metal object. Okay, so we have metal and we have non-metal, M prime. So M is for metal, and then signal, we're going to say detected, okay? I'm going to say signal, okay? So that means signal means it detects, okay? All right, so we got 25% of the objects are metal, so 75% are non-metal. And then now it says only of the metal objects, it detects 98% of them, so signal, so 0.98, which means that it does not give a signal for 2% of the metal objects. Of the plastic or non-metallic objects or anything like that, it detects 4% of them, and it does not detect or give a signal for 96% of them. So it says if the machine gives a signal, so that means given S, what is the probability that it's a metal object? Okay, so it's the probability of M and S divided by the probability of the given S. So M and S, that's this first pathway, okay? This one right here. And then on the denominator, you have the top pathway plus this other pathway, right? Where you just have a signal. So these two are the pathways for signal for the bottom. On the top, you just have the denominator, or the numerator, you just have M and S, okay? So yeah, 0.25 times 0.98 divided by 0.25 times 0.98 plus 0.75 times 0.04. Okay, we just calculate that and see what we get. So 0.25 times 0.98 divided by, again, put parentheses there. Okay, so you get 0.8909. Okay, so if it gives a signal, there's a 89% chance around there that he found the metal object. All right, guys, that's going to do it for the video. Hope you found this useful. And as usual, I'll see you in the next one.